Welcome to the Explainer. Today we're going to tackle three principles that are, well, pretty much the bedrock of the entire Java programming language.
So, have you ever wondered how massive Java applications, the ones with millions of lines of code, don't just collapse into a chaotic mess? How do they stay organized, reusable, and secure? Well, the answer comes down to three foundational pillars of object-oriented programming. And trust me, these are absolutely crucial for your exams and assignments. All right, let's dive in.
First up, pillar number one, scope. This is all about the rules of visibility. Basically, where in your program a variable or a method can actually be seen and used.
So, what's really crucial to get here is that scope isn't some kind of surprise that pops up while your program is running. Nope, Java figures all this out at compile time. The compiler acts like a strict referee, enforcing these visibility rules before the program even gets a chance to run. It all depends on where you physically place that variable declaration in your code.
Okay, listen up, because this right here, this is a guaranteed exam question. You've got two main types of variables to worry about at the class level. Think of instance variables as personal, private property. Every single object you create from a class gets its very own unique copy. What one object does to its copy has zero effect on any other. But then you have class variables, the ones marked static. These are like public property. There's only one copy, and it's shared by every single object of that class. So if one object changes it, boom, every other object sees that change instantly. And here's an exam tip that catches so many people out. A variable that you declare inside a code block, between the curly braces, or inside a for loop, it's like it has a super short lifespan. It only exists within that block or that loop. The second the loop is done, poof, that variable is gone. It just vanishes into thin air. So if you try to use it outside, like in this example, you're going to get a compile error every single time.
All right, let's move on to our second pillar, inheritance. This is basically the magic of how we can build new classes based on existing ones. It's all about reusing and extending code.
And the magic really happens with one simple keyword, extends. When you write class dog extends animal, you're not just linking two classes, you're creating what we call an is-a relationship. You're telling Java, hey, a dog is a type of animal. And just like that, the dog class automatically inherits all the traits and behaviors from the animal class. No need to copy-paste code.
Now this is another one for your theory exams for sure. Java has some strict rules about inheritance. It supports a few patterns. You can have a single class extending another. You can have a whole chain, where C extends B and B extends A. And you can have a hierarchy, where a bunch of different classes all extend the same parent. But here's the big one. Java does not support multiple inheritance. A class cannot extend more than one other class directly. This is a deliberate design choice to keep things from getting messy.
So what happens when a subclass inherits a method but wants to do things a little differently? That's where method overriding comes in. Look at this example. The animal class has a general each method, but for a dog, maybe we want to be more specific. So the dog class provides its own version of the eat method. It overrides the original. Now, when you call eat on a dog object, Java uses the more specific eating bread version, not the generic one. It's pretty smart.
Okay, so you can override a method, but what if you don't want to completely replace the parent's version? What if you just want to add to it? Well, that's exactly where the super keyword comes in. So this little keyword, super, is like a multi-tool. It has three key uses. One, you can use it to access a variable from the parent class, especially the subclass has one with the same name. Two, you can use it to call an overridden method from the parent. And three, and this one is super important, you can use it to call a parent class's constructor.
And here's a perfect example of that in action. See how the dog class has a work method? The very first thing it does is call super.eat. That tells Java, hey, go run the original eat method from my parent, the animal class. After that's done, it can go on and do its own thing, like bark. This is an incredibly powerful way to extend functionality instead of just completely replacing it.
And that brings us to our third and final pillar, information hiding. This is all about controlling access, which is absolutely essential for keeping your code secure and stable.
The whole idea here is to hide the internal guts of an object from the outside world. And the way we do this in Java is with something called access modifiers. You can think of them like doormen for your classes. They stand at the door and decide who gets to come in and who has to stay out. This protects your object's internal data from being messed with by other parts of your program.
Okay, this table, you're going to want to memorize this.
It's your cheat sheet for access control. At the top, you have public. That's the party animal, wide open to everyone, everywhere. At the complete opposite end, you have private. Think of this as your personal diary. Only code inside that exact same class can touch it. And then in the middle, you have protected, which is kind of like for family. It's accessible to subclasses, even in different packages. And default, which is what happens when you don't write anything, is for the neighborhood. It's only visible within the same package.
So, what's the big takeaway here for writing good, solid code? It's this golden rule. Make your instance variables private, always. You protect your data first. Then, if other parts of your code need to access that data, you make them go through public methods that you control. This gives you a chance to check the data and make sure nobody's doing anything they shouldn't. It's a cornerstone of building reliable software.
Okay, let's wrap this up and bring it all together. Here are the key points you absolutely need to remember for your exams.
So, remember these 3 pillars. They don't exist in a vacuum. They all work together. Scope defines where things are visible. Inheritance defines what a class is and lets you reuse code. And information hiding defines who can get access. You've got visibility, reuse, and security. Mastering how these 3 concepts interact, that's the real key to building well-structured, secure, and efficient Java applications. So think about that. This isn't just abstract theory for an exam. These are the fundamental design tools you'll use every single day. The next time you sit down to code, ask yourself these questions. What should be visible? What can I reuse? What needs to be protected? Because that's the blueprint for building truly powerful software. That's all for this explainer. Good luck with your studies.